Hello, this is Mr. Jackson, and today we're going to be doing a friction lab investigation. I'm going to be changing the camera in different directions and refocusing every so often, so be prepared for that. I want to just work through our lab one section at a time. Our first section asks us to weigh our block. So let's do that first, okay? Okay, the first thing we want to do is look at our scale here. Our scale is in newtons, as you can see, and you have these little lines. These little lines represent 0.1. So here we go. We're going to take our block and we're going to hook it to our spring scale to find the weight of this object. And we can see that this particular object has a weight of, if I hold it, oh, it's on the table, I apologize, has a weight of 2.2. It goes down to that second line. Maybe that's 2.1. Let's write down 2.1 newtons, okay? So continuing on, we know we have 2.1. Now the next part of this is we want to figure out if area has an impact on our block, because our block, does friction matter if I pull it on the skinny side or if I pull it on the bigger side? Will I get more friction? What do you think? Think about that for a second. Should I have more friction here, or should I have the same amount of friction on both sides, or should I have less here? So think about that. Sometimes people have to go through this. So what we're going to do is we're going to measure these and find the area. So let's find the area of our block. So we're going to start with the larger surface. So here we go. Measuring our block, putting it right here. You can see we have 1, and then it goes to there. So from that idea, we're going to assume that we have 12.4, okay, centimeters. Let's measure our other direction. We have off to the very edge. Remember, we got a little bit of rounding here. So that is going to be just a little bit beyond the edge. And then I can see it goes a little bit beyond the edge. And so I got from 0, and this looks like it's going to be, the width will be 8.7 centimeters. Okay? So there's your two numbers. Okay, write those down. Then we want to go, and then we want to find, it says that we're going to call that side A. So right here we have side A is the big side. Okay? Now we're going to go and measure the other smaller side, which is side B. So on our second page, see, we can see that with side A. We want to find the length and the width, and again, and put that in our lab. So let's go to side B, okay? And so we're going to measure that side B. B, for our area, which is length times width, we have a length that looks like 12.3. Okay, or no, 12.4. It's 12.4. I apologize, centimeters. And the width, giving it a little extra here to go around this curve. So it looks like there. And so I'm going to say it's going to be, looks like the width is 3.8 centimeters. Okay, so now you can plug those numbers in there and multiply them. Okay, then you'll have the answers for this situation. And then we want to go through now and see if our area has an effect on friction. So what we have to do is continue on and see. We're going to place the block on its smaller edge and then again on its larger side and check for friction. So to do that, we need to go to our data page. This is our data page. So now we're going to do side A, and we're going to find the friction, and then do side B and compare them to see if we get different friction. The reason I have two tables here is I want to use two different surfaces. So this is going to be surface 1, and I'm going to use our table right here. And then I'm going to do surface 2. I'm going to use a piece of cardboard from our friction board, okay? So let's do that. Okay, so our first problem, we're going to take and lay down side A. So this is side A, the big side. It's underneath down here. I'm going to pull it across the table with a smaller scale that has a smaller amount of units of newtons, okay? So let's do this. Here we go. Pulling it across, we're going to do it 3 times. Okay, I can see at constant speed, I'm right about here, it looks like 0.25. 0.25. So that would be your first number right here, 0.25. And that would go in this box, newtons. Do it again, just to keep checking ourselves. Do it 3 times, make sure we're not getting lost here. I pull it across, and it sees it stay constant speed. I got to do it at constant speed, so my force of friction equals my force applied. So 0.25, and we'll do it again a 3rd time again. Rotating it here, making sure I hold it flush so you guys can see it. Let's hold it better like this. There we go. And it looks like 0.25 again. Okay? Now we want to do the force of friction for this side, the side B. So what we're going to do is we're going to turn our block so it's like this, so the skinny side is down, and we'll pull it across table. We'll do it 3 times again. So here we go. We're going to pull it again. And it looks like 0.2, looks like 0.30, okay, because it went up just a little bit. 0.30. I'll pull it again to see. Oh, this time it's 0.25. It stayed pretty consistent. Let's pull it again one more time just to make sure. And I pull it across. At constant speed, I get 0. Less than that, 20. So the 3 numbers I have here for this one was 0.30, 0.25, and 0.20. Okay? And then what you want to do is add those up. Sorry, I didn't show you that here. There they are. These go in here. Then you want to add those up and divide and find the average. Let's see if it stays consistent on a different surface. Okay? Just in case my surface has an impact. Remember, we're trying to see if using different sides has a bigger or the same or no impact. Okay? So here's our cardboard surface. We're going to start with side A down. So that means you're going to be filling in this chart right here. Okay? And we're doing a different surface just to compare. Trying to be consistent. I'm going to pull it at constant speed, because constant speed means that then the force applied equals the force of friction. So I'm going to pull it this way, I'm going to pull it across, and I get a number of 0.5. So if you could see it, it was on 0.50. Let's try it again. Going across at constant speed, 0.50, the top of this curve right there. 0.50 again, pulling it across again on the A side, I get 0.50. So we have 3 readings that are identical. So we're going to use those 3 readings here and put them in. So these readings right here, 0.5, 0.5, 0.5. Okay? Those are the 3 numbers there. Now let's turn it on to our B side. Okay, so we're going to turn it from here to here, and let's run this problem again. Here we go. Pulling it across. Okay, making sure I'm using just that side. I pull, and I've got to turn it here a little bit for you. I turn my there we go. So you can see the scale. Here we go. So you know it. See, it starts a little higher, and then, well, I got to pull again more consistently. I'm sorry, guys. And it looks like, a little bit less. I got 0.40, right? It was a little bit less than the 0.5. Okay? Let's try it again. Pull nice and consistently. And I have, it looks like it bounced around, but look at 0.5. Pull again the final time. 0.5. So, we have 3 numbers here. We're going to use these 3 numbers are 0.40, 0.50, and 0.50. Okay? So those are your 3 numbers. Add them up and divide by 3, and you'll now have your average for using side A or B. Now I want you to understand, if there's a noticeable difference, this is twice the area of this one. So if it really has an impact, there should be a big difference from this friction to this friction. If there's only small differences, then that means there is no difference, and so surface area has no impact. Okay? So I want you to figure that out, and then you can answer these questions down below. So that's your job. All right? Let's go to the next part. Our next part is we want to take and pull this box or a block of wood across different surfaces. We're going to use the cardboard, the cork board, the sandpaper, and this one, our old one had rubber, but now we're going to have the laminate. So you need to change this word right here. I apologize, I did not get it to you. We'll just say laminate. Okay, or if you want to call it this smooth surface right here. Okay, so we're going to change the name of this last one. Okay, in both charts. Okay, and if you just write it down there as laminate, that's fine. It's okay with me. So here we go. We're going to pull it across 3 times and then find the average in this box. And then what we want to do is we want to find forced normal and then divide these two and find how rough the surface is. So we're trying to find how rough all 4 of our surfaces are. So here we go. We're going to be doing something really unique. But let me stop for a second, and we need to find the weight of our block again. Well, we knew we did find it already, 2.1. But we're going to use 2 other blocks too, so we'll get to those in a minute. But let's just use the one block, and we know our weight, or our F of weight, is equal to our Fn. So in our Fn right here, since it's one block, you can write 2.1, 2.1, 2.1, 2.1. We measured that already. All right? Let's move on. So now we're going to do the cardboard first. That is this one. I'm going to adjust my camera here so I can see it better. There we go. So here we're going to pull our block across. It doesn't matter which side we used. You found that out from the last unit. We're going to pull it across 3 times and figure out what is the friction we encounter on this one. I got to spin my thing. Here we go. So pulling it across 3 times, really nice and smooth. At one constant, I get 0.5. 0.5. Pulling it across again, I get 0.4. Pulling it across a 3rd time, I get 0.5. So our 3 numbers here are 0.4, 0.5, and 0.5. You want to now add those all up and divide by 3 and put them right there. The weight is 2.1. And now you can find mu in a few minutes. Let's finish and get this done really quick and get cork now. This is cork board right here. So we're going to use that to go across. Pulling it here, and I pull it across, and I get a number of, I got to do it for you here on the screen. Move my camera down here so you guys know I'm not cheating you. I get a little higher than that. So at constant speed, I had 0.6 right there. And I do it again. Oops, it's getting caught on something. There we go, nice and smooth. I get, again, it bounces around 0.6. And then let's do it again here. And 0.6, okay? Let's do now, so 0.6, 0.6, 0.6. Let's do our sandpaper. Here we go. We should get a little bit higher number here. I'm trying to pull it nice and consistently across. And it's dark, so it's going to be hard to read the numbers. I'll read them for you. And I have down to here, a little higher than 1.5, and it held it near a little bit higher. So I'm going to go 1.55. 1.55. Okay? Pull again. 1.5. Do it again. And that one a little higher. That looks like it's averaging 1.70. Okay? So there we go. There it is. We had sandpaper. We had 1.5, I think 1.6, 1.5, 1.7. Okay? Now we're going to do our laminate, which is the rubber one, which is this yellow part right here. So I'll spin my block around here for you really quick. Here we go. Pulling it across. Looking at our newtons here. Make sure it's not on the sandpaper there. We have, looks like 0.55. Pulling it again. A little bit above. Now that one's 0.5. That stayed at 0.5. And then doing it again one more last time. And it's a little bit higher. Looks like that. So looks like 65. So we have 0.55, 0.5, and 0.65. That's the reason why we do it 3 times. Add them together and find the average. And then again, this is 2.1. Now let's find the value for mu. Okay, for each one of those. That's your job right now. You can pause the video. Now, if you pause the video and you're back, what we're going to do is we're going to take 2 blocks of wood, and we're going to add them together and hang them up and find their weights like I did the first time to find the other blocks. Let's do that right now. Okay? Okay, just like I did last time, I've hooked my blocks to my other spring scale to weigh these, and if I let it weigh back down, and you can see it falls about 2 lines below the 2. And so that's going to be, if each one is 0.2, that's going to be 1.8 newtons. Okay, 1.8 newtons. Okay, to clarify where we're at, we weighed the first block, its weight, which is equal to the F end of the scale. That was 2.1 because we only used 1 block. Now I'm going to take this block, the 2.1 Newton block, and I'm going to add these 2 on top to give it more weight and more force normal on my surfaces. Okay, so we need to add all these numbers together. So we had the other block, which was 2.1 newtons, and then the 2 blocks together was 1.8 newtons, and so we have 3.9 newtons as our total weight. And so if our weight is 3.9, then our force normal is 3.9. So this is 3.9, 3.9, 3.9, and 3.9. Okay? So we're going to see if our friction or our coefficient of friction stays the same. My friction should go up because I have more weight, so I have more normal. This should go up, but also at the same time, since it goes up and I divide, I still should get the same value as I do up here. Now there are going to be some slight differences because we're just using a simple spring scale and pulling things across a crude table. But let's see how it works out, okay? Let's do this. Here we go. Let's bring our surfaces back up here. Put my blocks aside. We'll start with our cork board again, which is our top one. We'll do it 3 times. And here we go. So we have our 3 blocks all stacked together. We're going to pull it across, and we're going to try to figure out what the force is. Okay, pulling it across, more friction. I see it registering right here at 1.0 newtons. Okay, 1.0 newtons. Pulling it across again as evenly as I can at constant speed. It goes high and then goes across. Whoop! Try it again. Takes a few times to do it. Practice it. That time it ran exactly again at 1.0 newtons, stayed the same. Okay, pulling it again at consistent speed. Got it. Remember static, and then it goes to kinetic. I want kinetic only. That time it weighed a little less, so I'm going to put 0.9 newtons. 0.9 newtons. Okay, so we have our 3 measurements. It's 1.0, 1.0, and 0.9. You want to add them up and divide by 3. Okay, let's do it again now on the cork board. Here we go. 3 times. We have 3 pulls. We got to go this one. This one is going to go, it looks like again, that looks like 0.9, 0.9 for our cork board. Doing it again. That looks like it's a little bit above, so I'm going to call it 1.1 newtons. Again, pulling it across. And again, it looks like 1.1 on the average. Okay, so we have those 3 numbers going across for the cork board. Let's do the sandpaper now. Here we go. We have the sandpaper. And we're going to pull it across. So here we go. Ooh, that's swimming. Oh, let's get. Oh, it maxes that one out. So I've got to change to a different scale. And this one goes from 1 to 5 newtons. That was way up above 1 newton. Let's see if I can change this new scale. And you can see it says newtons right here. Right here. Let's see if I can use this one. Ooh, it bounced around, so I got to practice this a couple times. Okay, I got 2.75 newtons. It registered right down in here at 2.75 newtons, just down there. Let's do it again. It bounces around, so I got to take an average as what I see. Pulling it across. And that one pulled around 3 newtons, right around down here. It moved around. And then again, that one is there. So that goes 2.8 newtons. 2.8 newtons. Okay? So that's the numbers you would have there. So that's your sandpaper. Now we're going to go back to our laminate again. Here we go. Our last 3 pulls, I can go back to my lighter scale. Here we go. And we're pulling it across. We have these. So we're pulling across my scale. That is that looks like it's going to be 0.75, 0.8, so let's 0.9 again. Let's go 0.9. That one was a little bit smoother. That was 0.85, 0.85. And let's do it again because it's above 7.5. And that one again is 0.85. So let's do those. So we had 0.9, 0.85, 0.85. Okay. Now you want to add these 3 together, find their averages. Okay. And then we have that new way to 3.9. You want to divide them and find the mu. And let's see how close they are to each other. Now they're going to be different, but are they least reasonable by this raw, simple method? Then I want you to answer these questions. All right? Thanks a whole bunch and appreciate you doing the lab.